Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss some questions, past paper questions for International A-Level Edexcel P2, Pure Mathematics 2. And here we have a past paper handout for chapter number 2, which is coordinate geometry, particularly equation of circle. So first of all, we have handout question number 1, which is June 2005 C2 question number 8. So the question says that the circle C with center at the point A has equation x square plus y square minus 10x plus 9 is equal to 0. This is basically the expanded form of the equation of the circle. The requirement of part A is to find the coordinates of A. We need to find the center of the circle. Okay, so first thing first, we are going to convert this expanded form into a completing square form. And for that purpose, first I rearrange the equation in this form that the terms in x are together and the term is y is only one term, which is y square, and the constant term on the other side of the equation. Okay, and the formula for the completing square form, which we are studying since P1. So basically my approach is to convert the general form of the quadratic expression into a completing square form in this way, that the general form of the quadratic expression is in the form ax square plus bx plus c. So in order to convert this into a completing square form, we use this formula: a times x plus b over 2a whole squared plus 4ac minus b squared divided by 4a. All right. So my approach is basically to consistently use this particular formula to convert a general form of the quadratic expression into a completing square form. Okay. So an equivalent form of this formula is also given to you in the P1 book. So the thing is that first you just focus on this x square minus 10x. Okay, so I've converted this into a completing square form using this formula: a times x plus b over 2a whole square plus 4ac minus b square divided by 4a. And there is only one term in y, which is y square. Okay, and the constant term will be shifted on the other side of the equation. So when this is converted into a completing square form, this gives us x minus 5 whole square minus 25. Meaning when x square minus 10x is converted into a completing square form, this will give us x minus 5 whole square minus 25, and then plus we have y square over here, and this is equals to minus 9. So I can say that x minus 5 whole square plus y square is equals to minus 9 plus 25, which is 16. So we have, achieved the completing square form of the equation of the circle, or you can say a standard form of the equation of the circle, which is x minus a whole square plus y minus b whole square is equals to r square, where basically the center of the circle is a comma b and radius is r. Okay. So I hope you have covered the basic concepts before starting the past paper questions. So if we just make a comparison of these two forms over here, so we can say that a is equals to 5 and basically b is equal to 0 because we have only y square over here. So a is equals to 5 and b is equals to 0. Therefore 5 comma 0 is the center of the circle. 5 comma 0 is point A. This was the requirement of part A over here. Now in part B, we need to find the radius of the circle as well. Okay, so since we have identified the fact that r square is equal to 16, so r square will be kept equal to 16. So r is equal to square root of 16. So r is equal to under root of 16. And since we are dealing with the radius, so radius is basically a length and length is always positive. So positive is square root of 16, meaning 4 units will be your answer. As simple as that. The radius of the circle will be 4 units. Then we have part C, which says that you need to find the coordinates of the points at which the circle crosses the x-axis. So very simple. At x-axis, y is always equal to 0. Okay. So we have kept y is equal to 0 into the equation of the circle. which was given to us in an expanded form in the question. So in place of y, I kept 0. So we were able to get this quadratic equation over here. X square minus 10x plus 9 is equal to 0. And then I factorized it. So therefore x is equals to 1 and the other value is x is equals to 9. So therefore, the coordinates of the points at which the circle crosses the x-axis is 1, comma 0 and 9, comma 0. Okay, so this is your answer to part C. Then in part D, it says that given that the line L with gradient 7 over 2 is a tangent to the circle, and the line L will basically touch the circle at point T. Okay. The requirement of part D is to find an equation of the line which passes through A and T. Okay, so basically the tangent to the circle has a positive gradient. So this means that, these are the two possible lines over here. This makes sense because we have a positive gradient. So either this can be this point or this point. Okay, so these are two possible positions for point T. All right, so point T is over here and another point I've made, T complement you can say. These are the two possible positions of point T. What we want, we need to find the equation of the line which passes through A and T. Okay, so first thing first, as we already know the fact that the angle between the tangent and the radius is always equals to 90 degrees, since the radius is always perpendicular to the tangent. So it's basically the concept which you are studying since O level and IGCSE mathematics, which we have also used in P2 over here. Okay, so the basic concept is that, this tangent and radius are perpendicular to each other. So we can say that the gradient of the line L multiplied by the gradient of AT is equals to -1. And since the gradient of the line L is given to you in the question, so gradient of AT is supposed to be -2 over 7. This makes sense. Okay. So when we are going to find the equation of the line which passes through A and T, so it has a gradient of -2 over 7 and it passes through point A, which we already know over here, which is 5, comma 0. Okay, we are not concerned with finding the equation of the line L because there are two possible positions for the line L. We are interested in finding the line which passes through A and T. So basically the whole line which passes through A and T. Okay, so this complete line we are finding the equation. Or you can just consider this radius over here, since the radius is also the part of the line AT. Or you can say radius is also the part of the complete line which passes through A and T. All right. So this is basically the whole idea behind this. So gradient of AT is -2 over 7 and it passes through the point A, which is we have already found in part A, which is 5, comma 0, which is the center of the circle. So y minus y1 is equals to m multiplied by x minus x1. So therefore y is equals to -2 over 7 into x plus 10 over 7. This is basically the equation of the line AT which we are looking for. Alright, so this was basically handout question number 1. So now let's move on to the next question. So up next is basically handout question number 3, which is June 2006 C2 question number 7. Okay, so the question says that we have a figure over here. The line y is equals to 3x minus 4 is a tangent to the circle C. Okay, and this tangent will basically touch the circle at point P, which is 2, comma 2, as you can see in figure 1. The point Q is basically the center of the circle. Okay, and in part A, we need to find an equation of the straight line through P and Q. So first of all, we can identify the fact that the gradient of this tangent is 3. From this equation, we can say that the gradient of this tangent is 3. And as we know the fact that angle between the tangent and the radius is always 90 degrees. Okay, so then we would be able to find the gradient of the line PQ. So here I've done the working over here for part A. Okay, I can say that the gradient of the tangent multiplied by gradient of the line PQ is equals to -1. So 3 multiplied by PQ is equals to -1. Therefore, the gradient of the line PQ is -1/3. And since we know the fact that the line PQ passes through the point P, which is given to us in the question, which is 2, 2. So I have found the equation of the straight line by using this form. Y minus y1 is equals to m multiplied by x minus x1, and then I rearranged the terms and I expressed my equation in the form y is equals to mx plus c. You can also give your answer in the form of ax plus by plus c is equal to 0, because in this specific question a particular form is not asked. So this was part A. Then in part B it says that in part B the information is that given that Q lies on the line y is equals to 1. Okay, so point Q is on the line y is equals to 1, which is a horizontal line, which means that the y coordinate of Q is 1. X coordinate we don't know. We need to show that the x coordinate of point Q is 5. So since I have found the equation of the line PQ, I can just substitute the value of y is equals to 1 in the line of PQ. As simple as that. So I've just mentioned that point Q is in the form of x comma 1, where x coordinate is unknown right now. So in place of y, I will keep 1, and this will be equals to -1/3 into x plus 8/3. So x will be equals to 3 multiplied by 5/3, and therefore the x coordinate is equals to 5. In this way, we have shown that the x coordinate of point Q is 5. After this, we need to find the equation of the circle. We need to find equation for C. So we have already identified the center of the circle, which is point Q over here. So the circle is having the center 5, 1. So we can just use this form, x minus a whole square plus y minus b whole square is equals to r square, where a is 5 and b is 1. And in order to find the value of r square, we can just substitute point P over here, because you know the fact that point P is on the circumference of the circle, which means that point P actually satisfies the equation of the circle. Okay, so this is basically the whole idea. So x minus 5 whole square plus y minus 1 whole square is equals to r square. Now in order to find the value of r square, we can just substitute point P over here, which is given to us 2, 2. So in place of x, we have substituted 2, and in place of y, we have also substituted 2. So 2 minus 5 whole square plus 2 minus 1 whole square is equals to r square. So r square is equals to 10. Okay, so therefore, equation of the circle is x minus 5 whole square plus y minus 1 whole square is equals to 10. In this way, we have attempted this question as well. Okay, so this was basically question number 3 of the handout, which is June 2006 C2 question number 7. So for the purpose of this recording, for the sake of this recording, I've discussed these 2 questions. So I'll be discussing some more questions in my next videos. Stay tuned to my channel. Thanks for watching.